Hello friends, welcome. Friends, this is the module 3 of the satellite technology course which I've started recording, and many of my viewers might have already seen other two modules. So just to recap, the module 1 was foundation of satellite system, and the chapters which I had covered in module 1 is been listed in right in front of your screen. And then module 2 was satellite spectrum bands, and the chapter that I covered is just in front of your screen. And now today we are going to talk about satellite network architecture, and these are the chapters which I am going to cover in this module. We are going to talk about satellite internet architecture, how it is different from terrestrial system, what is the concept of bent pipe. Then we are going to talk about inter-satellite links. What are they? What purpose they serve? Why ground networks prefer optical fiber? Because satellites are using laser, and when we talk about base stations and the terrestrial networks, we typically use optical fiber. And why satellite we don't use optical fiber, or how satellite is able to live with laser links. We are going to talk about that. And the satellite lifetime, rogue satellite, and deorbiting. And what is the role of deorbiting and how critical this aspect plays in the overall satellite network deployment architecture, which is quite different from the terrestrial base station architecture, where you really don't have to think about decommissioning a base station in the manner which we decommission satellite, right? So let's start with satellite internet architecture. The user terminal connecting to satellite, satellite connecting to gateway. So friends, let's look at this animation. Now in this animation, you see a user terminal here and you see a gateway station. So what the user terminal is doing is, it is talking to the satellite. So satellite is acting like a mirror, and then it is going out into the internet backbone. So this is a both-way communication. So this is typically the way the satellite networks work. The user terminal uses the satellite as a reflector or an active reflector in the sky. And the base station, it is a little different. But here, since the satellite doesn't have any kind of physical architecture to rely upon, as you have in case of terrestrial network, it has to rely heavily on the gateway. Now, the gateway is quite limited. You can't have multiple gateways. Like in case of terrestrial network, you can have multiple gateways, which are kind of a hub and spoke kind of structure. Here, you can have only 2-3 gateways per country, and therefore satellites relying on gateway is pretty important. So let's understand that. Otherwise, without the gateway, the satellite will not be able to talk to the internet. For internet, it has to have a gateway, and the user terminals are all talking to the satellite, and this becomes an aggregated point. So this is point number 1, which I wanted to discuss with you. Second point is the bent pipe concept. Now friends, this is pretty important. What is this bent pipe concept, right? So these are the points we are going to cover. Satellite receives signal, amplify the signal, then retransmit the signal to the ground gateway. No complex routing happens inside the satellite. Now let's understand what is bent pipe. Now friends, this bent pipe thing is right here. So if you look at the user terminal talking to the satellite, talking to the gateway. Now you might notice one thing, because currently it may not appear in the diagram as it, but this whole thing is falling under the footprint of the satellite. This is pretty important, friends. It has to be under the footprint of the satellite. Means the satellite, it should be visible to the user terminal as well as the gateway simultaneously. And if it is not, then this whole thing is not going to work. Because let's assume that the satellite moves away from the horizon, and suddenly either the user terminal may be visible, but the gateway become invisible to this satellite. Now, if the gateway become invisible to the satellite and there is no satellite to take over, then this user terminals, even though it is connected to the satellite, will not be able to talk to the internet, because the satellite to which it is talking doesn't have the visibility of the gateway. You understand? This is called bent pipe concept. And this bent pipe concept is typically used by many systems because this is quite simple to implement, and there are no complicated electronics to be implemented to able to the user terminal to talk to the internet, right? So that is one. Right? Then we have this inter-satellite laser links. satellite communicating with each other using laser link. Data can travel across multiple satellites in space, reduce dependency on ground gateways, enables global coverage with satellite constellations. Now, this is the inter-satellite links, friends. Now, what you see here, you see a user terminal and you see another satellite, and then there is another satellite, the second satellite, and then there is the third satellite. Now, friends, what may happen that the user terminal here, what you see here, the user terminal, it may be under the footprint of satellite 1. The gateway may not be in the footprint of satellite 1, right? But in order for user terminal to get out into the internet, what it does, it goes here and then through another satellite, which is the inter-satellite links, which are in laser. Using this inter-satellite link, it kind of gets diverted to a satellite 3, which has visibility to the gateway. So the gateway may be visible by, through a different satellite. So all the user terminals which are located within anywhere in the earth which has visibility of at least one satellite, they can talk to the internet even though there are no gateways nearby which is in the same visibility of the satellites. Do you understand? So this inter-satellite links play a very important role. Now, friends, the question comes, why these inter-satellite links are not in radio frequency? Why they are in laser? The reason is that there is a huge complexity in managing satellite frequencies. These satellite frequencies are all of different nature in order to prevent interference, which we have already spoken in the earlier module. Now, think that how much confusion it will create that we start radiating in RF frequency, because then you have to manage spectrum and the spectrum management will become very difficult and it become a nightmare. So instead of using RF, they use laser. Laser can be pretty easily managed and they are focused, right? And because they are focused, therefore, two satellites can easily talk to each other without involving any RF network. And laser can play a very important role here. But friends, then the question comes, then why on ground we don't use laser? Typically when talking to there are laser which can be used, and some people have come out with laser, and I have already made one video on the topic, but typically it is not used. The reason it is not used, friends, that if you had used laser to talk from this point to this point, the laser is very sharp. And if this terminal shakes because of wind or any other reason, this alignment will break, because there is a 1 degree or even a 1 minute of misalignment within this terminal, and that laser beam which is floating to the other terminal, that terminal will get misaligned. But in space, this kind of misalignment does not take place because space is reasonably empty, there are no interference, and the satellites are reasonably stable, and therefore this kind of misalignment does not take place, and therefore this inter-satellite links typically work well. Then comes we have already spoken about it, why ground-based network use fiber and why not laser. Now, satellite lifetime and deorbit. Now, friend, this is also a very, very important concept to understand. What is it? For that, we have to look into this animation, which I had already showed you in one of my earlier module. Now, friends, you see one satellite is revolving around the surface of the Earth. Now, the surface of the Earth is not perfectly round. There are undulations. Since there are undulations, when a satellite is revolving around the surface of the Earth, the orbit may not remain perfect. So what will happen? I'm going to show you. Let's say the orbit start losing the stable orbit. The satellite becomes a little bit of wobbling from the central stable orbit, and it kind of wanders a little here and there. So what happens is that, look, this is how it happens. The original orbit track was this. Now the satellite has got misaligned. If it misaligns too much, then it may go and crash into the surface of the Earth. Now, in order for the satellites to remain in orbit, rocket fuel has to be, embedded into the satellite so that the satellite can, speed up, or realignment can be done, and then the orbit can be reached. By doing all this little bit of realignment, the original orbit position can be reached. So this is how a satellite is maintained in a stable configuration on the surface of the Earth. Now, what happens is that after some time, this fuel in this satellite becomes it exhausted, because you can't have solar terminals of the satellite cannot be used for rocket energizing this rocket fuel, or it cannot be substituted for rocket fuel. So as soon as the fuel get exhausted, then what happens is that the satellite will crash into the surface, on the orbit. The orbit of the satellite become lower and lower, and it will crash on the surface of the Earth. And in order to prevent such event, there is a controlled decommissioning of satellite which takes place. So you bring the satellite closer to the surface of the Earth, and as you bring closer and closer, it kind of controlled decommissioning of the satellite happens in order to ensure that satellite does not fall in anybody's head. So this is very pretty important aspect of satellite, and therefore satellite is a very resource intensive activity. It requires a lot of money and resources to be deployed, because every 5 years the satellite has to be decommissioned. Otherwise, it will crash. See, it has crashed on the surface of the Earth. So that's all, friends. So summary of this discussion is that key takeaways that satellite networks act as infrastructure in space. Bent pipe satellite relay signal between Earth station. Modern constellation use laser link between satellite. Ground networks rely on optical fiber for stability. Satellite life cycle management is critical for space safety. Thank you, friends. I will come with a new module and as I extend this course further.